Welcome to this introduction to Powergate. Powergate provides one single convenient API to store data across IPFS and Filecoin. In this video, I will introduce IPFS and Filecoin, and I will show you how to set up Powergate. We will then communicate with Powergate using the CLI, and afterwards look at some code which shows how to use Powergate from a web app. IPFS is a peer-to-peer storage network. You can add a file to IPFS, and IPFS will return a CID. CID stands for Content Identifier and is basically a cryptographic hash of a file or a directory. With this CID, anyone who participates in the IPFS network can retrieve your file. He can not only retrieve it, he can also verify that the data has not been tampered with. When you add a file to IPFS, it will automatically be pinned on your local node. That means that the data will be stored on your node until you unpin the file. Other nodes may start storing blocks of your file temporarily if it gets requested from somewhere in the network. If the data is not requested very often and all nodes that are pinning the file go offline, the file might cease to exist on the IPFS network. Filecoin is also a peer-to-peer storage network, but on Filecoin you can pay a storage miner to store your files. You can find an agreement on the distributed marketplace for storage deals. Once such a storage deal is in place, the network will make payments to the storage miner and enforce that the storage miner is indeed storing the files according to the deal. On Filecoin you can also pay a miner to retrieve content. To summarize, on IPFS, you don't pay for storing content, but you also have no guaranteed availability. On Filecoin, you have to pay, and you also have a guaranteed availability. To make use of the endowments of both of those storage systems, there's Powergate, which enables you to use IPFS and Filecoin through one convenient API. In Powergate, the IPFS storage is called hot storage, and the Filecoin storage is called cold storage. It's usually faster to retrieve data from the hot storage. But if the file is not available on the hot storage, Powergate can go to the cold storage and retrieve the file from the Filecoin network. By this, Powergate implements a multi-tier distributed storage system. Powergate offers a remote procedure call interface, and there is a CLI to interact with it. Clients for the grpc service are available in JavaScript and Go, and there is a community project called Powergate that implements a Python client. In order to set up Powergate on our local machine, we need those three components in place: Powergate daemon, an IPFS node, and a Lotus node. Instead of the Lotus node, which would need to sync with a Filecoin mainnet or a testnet, which can take a lot of time and a lot of resources, we can also use Lotus DevNet. And instead of setting up these three nodes manually, we can also simply set up Powergate Localnet, which comes bundled with all of these three components. Let's set up Powergate Localnet on our computer. Go to GitHub and clone the repository textile.io Powergate. I've already done that. Change directory into the repository and then change directory into the folder Docker. There you simply run make localnet. When you run this the first time, it might take a while, and then if you run it again, it's quicker. I will stop the output for a second and let's have a look at this. We can see that there's three containers running: Lotus 1, Powergate 1, and also IPFS 1. These are the three components that are required for Powergate. If you want to know the settings that Powergate was started with, have a look at these logs. Later, for example, we will need the grpc web proxy address. Now that the localnet is running, we can start using the CLI. In order to use the CLI, you go to the root of the repository and execute make install. Afterwards you will have pow available on your system. If you execute pow, you get a nice list of the available commands. And if you, for example, type pow admin, you can see the available subcommands of the admin command. The most commands that we will run with pow will be associated to a specific user. So let's create a user first. Pow admin create, pow admin users create will create a user and will return the user ID and the token. The token is important and we need to specify it with every Powergate command that we run. Instead of doing pow command -t and then providing the token here, we can also conveniently store it in an environment variable. Export pow token and then this token. Now we can do things like pow wallet addresses, which will give us the addresses that are associated with this user. Because we are on Localnet, we get some initial fund. Yes. Alright. Let's store a file using Powergate. When we store a file with Powergate, we can specify how we want the file to be stored in a configuration. There is a default configuration that we can have a look at with pow config default. I will put that into a file so that I can easily edit it. Let's have a look at the config. There's one big part about the hot storage and one big part about the cold storage. If you want to know what all these options mean, you can go to the Powergate documentation and click on Store Data and Storage Configs. A bit further down, you will find explanations for all the storage options. For example, the option Allow Unfreeze specifies whether Powergate will go to the cold storage to retrieve a file if it's not available on the hot storage. We can leave the storage configuration like it is and apply it to a file. But before we can apply it to the file, we have to stage the file, which will put it on IPFS. We can do this with pow data stage, and I have prepared a small test file. This will return a CID, and we can now use the CID to apply the config to. Pow config apply watch and the CID. This will start a new job, and we, because of the -- watch, will be updated about status changes of the job. The deal status has just changed to storage deal ceiling, and now the job has succeeded. Okay, now that the job has finished, we can retrieve the file from the hot storage by typing pow data get and then the CID of our file and some output file. Done, success. We can have a look into the output file and make sure that the content is the same as the content from the test file. Okay, let's try to change the config for this file now by first changing the config. Let's disable the hot storage and then apply this pow config apply. We use the config from this file that we have just amended, and we specify -o in order to override the config of this file behind the CID. And we can also specify --watch if we want to be kept up to date about the progress. That's very fast because no interaction with the Filecoin network has to be done. What we can do now is we can interact with the IPFS node that's running in the Docker container, and show all the pinned files, for example. We can see that this file with the CID that's ending with Q7 is not anymore pinned on the IPFS node. That's because we've disabled the hot storage. If we now do IPFS or docker exec localnet IPFS 1 IPFS and then repo garbage collect, it will remove all unpinned files that have somehow been stored on our IPFS node. You can see that the IPFS CID ending with ARQ7 has also been removed. If we would now try to get this file from the hot storage, we would get an error. But the file is still stored in the Filecoin storage. So what we can do now, for example, is we edit the config once again and we switch enabled for the hot storage to true and also allow Powergate to unfreeze the file from the cold storage. No, doesn't matter. And now we can do the same thing again as we did earlier. powerconfig apply -c default config, which we amended again, -o for override and watch. And Powergate will retrieve the file from the cold storage and put it into the hot storage again. The job has succeeded and we can now try to get the file, and now it's working again. We can also have a look at the pinned files on IPFS, and there we will also find this CID again. And what we can also do is we can do pow data log and find some information about what happened to this file. And in this log we can see that somewhere we I think here, executing hot storage configuration. This is where we re-enable the hot storage, and Powergate is then unfreezing the file from Filecoin because it couldn't get it from IPFS. And here you can see some logs about Powergate retrieving the file from Filecoin. And in the end, the file was successfully unfrozen and put into hot storage again. Alright, now that we have used the CLI, let's check out one of the APIs. If you want to use Powergate from a JavaScript application, you need to include this dependency, textile Powergate client. I have chosen to build a small Vue web app that makes use of the Powergate API. The website looks like this, and I will walk you through the important parts of the code. We will skip the HTML template code and have a look at this line. In this line we are simply importing create pow from this dependency. In this line we specify the grpc web proxy address. We have read that from the Localnet logs. And in this line we create an object pow, which we can use to interact with Powergate. We execute create pow, which we imported from the dependency, and as a parameter we specify the host address. When the web app is opened, we will initially load some information about the Powergate daemon by executing this pow build info. We store this into some variable which we will print on the website. Let's have a look how it looks. So here is the Powergate daemon build info. In the next step, like when using the CLI, we need to set or create a user. Let's have a look in the code what happens when the user clicks on create user. We do the same thing that we did when using the CLI. We execute pow admin users create, and we also get back a user ID and a token. In this method, we set the user token to a string that we can display, and we also execute pow set token and the user token. This does something similar like setting an environment variable when using the CLI. After the token has been set, we also load some information about the user in this function by calling pow wallet addresses and pow storage config default, and storing the addresses and the default config into variables that we display on the website. Let's have a look. I click on create user. Here is the user token of the user that we've just created. Here are the addresses of the user. There's only the initial address for now. And here is the default config that's in place for this user. In the next step, the website allows the user to choose a file and persist it on Powergate. Let's have a look at the code again. When the user clicks persist, we will first stage the file and then apply the config. For staging the file, we execute pow data stage and we get a CID in return. Using this CID, we apply the config to this file by executing this pow storage config apply and then the CID as a parameter. When this function has executed, we add a job object to a list of jobs so that we can display all the jobs that are currently running on the website. We also start watching jobs so that we can update the status of all the jobs. This can be done by executing pow storage jobs watch, which will inform us about any update about any job. We make sure that the job ID of the update matches the job ID of one of our jobs, and then we set the status string according to the status code. Okay, so I will choose a file now. I will choose this image and click on persist file. Here appears now one entry, and here is the job status that is currently executing. In the meantime, I can choose a different file, maybe a file that's too small, where an error will occur. Yes, in this case you can directly see that the job has failed because the file size was too small. Let's wait for this job about the image to finish. In the meantime, we can prepare the retrieval of this test image. In order to retrieve the file from the CLI, we need to copy this user token and set it as an environmental variable. We will later need the CID, so I will copy it and prepare the command pow data get and the CID and then the retrieved image PNG. Now let's wait for this job to finish. Oh, it already succeeded. Great, let's go to the CLI and execute this. Success, the data was written to retrieved image. Let's have a look. Voila, there it is.